International Outreach Committee in Tunisia and also a member in the Tunisian Association of Young Astronomers. She is also participating in many outreach projects linked to the Office of Astronomy Outreach of the IAU, and today she's gonna give us talk about Artemis mission. So, Asma, you can start.
Thank you, Maisa. Hi, everyone. I hope that you and your family are doing well because of the coronavirus. I thank the Arab Astronomical Society, the Jardini Astronomical Club in Morocco, the star shine for everyone with Mr. Jean-Pierre Coutard from Belgium for this collaboration. And today I will talk Artemis Program. What's this program? What's its architecture, its missions? In this presentation, I wanted to show you at the beginning a video. There is two videos. That when I tested the video, the quality is very, very bad on this Zoom meeting. So we will try to download this presentation and the two videos after the talk. Okay. So what is Artemis Program? Artemis Program is the twin of Apollo Program, which is celebrated its 50th anniversary last year 2019 for its mission Apollo 11, the first human landing on the moon in 1967. So when I tested the video, the quality is very, very bad on this meeting by 2024. And why? To prepare for Mars. Now the question, why NASA has chosen Artemis as the name of its program and not another name? So in Greek mythology, Artemis is the goddess of the moon, and she is the daughter of Zeus and the twin sister of Apollo. That's why at the beginning I say it's the twin of Apollo program. Now the big question, how is NASA going to the moon? So the answer is with sustainable architecture, which is composed of 6 parts. The Exploration Ground Systems Program, the Space Launch System rocket, the Orion spacecraft, the Lunar Gateway, the Lunar Landers, and with Artemis generation spacesuits. So I will start by the Exploration Ground System, which is one of the 3 programs based at Kennedy Space Center, including Commercial Crew and Launch Services Program. So this program, the Exploration Ground System programs, was established to operate and develop the facilities and the processes to launch the rocket and the spacecraft. I will talk about them later. During the assembly, which means to safely connect the rocket with the spacecraft, the transport, in other words, to move the mobile launcher to the launch pad, and I will talk about them later also. And finally, the launch to space. So the Exploration Ground System programs is upgrading now the equipment, the management, and the operations required to these 3 processes, such as the vehicle assembly building, which is in the Kennedy Space Center, and it is the only facility where it is served to assemble the rocket and the spacecraft. And now the mobile launcher. So this is okay. Concentrate please with the mouse. So this is the mobile launcher, and these are the crawlers. So the mobile launcher is the ground system that is used to assemble, process, and launch the space launch system rocket. We'll talk about it later, and the Orion spacecraft, and the Orion spacecraft, excuse me. So the crullers are called also cruller transporter. They are used to move the mobile launcher with the rocket and the Orion spacecraft from the vehicle assembly building to the launch pad. And this is the launch pad. Actually, the launch pad is the rocket launch site. It consists of 3 pads, 3A, 3B, and 3C. But in Artemis program, NASA will use the launch pad 39B. Excuse me. I will show you two pictures to more understand the processes. So this is a Space Kennedy Center. These are the crullers. This is the mobile launcher, and this is the rocket connected to the mobile launcher. Of course, this is the vehicle. This is the vehicle assembly building. It's actually a real picture. This is another picture. It's not a real picture. This is an artist concept. You can see here the mobile launcher, the rocket with the crawlers, the rocket connected to the mobile launcher. Now I will talk about the recovery operations. Actually, the team led by the Exploration Ground Systems program will be responsible for the operations of recovering of the capsule and the crew after landing. Here, it's very important, the spaceport command and control system. This part will control, monitor the equipment using for launch. When I tested the video, the space quality is very bad on this meeting. The heart of the spaceport command and control. It's very important, the spaceport command and control. All the activities, including the preparation of the rocket and the spacecraft and the pilots for the space, are controlled by engineers sitting in the firing rooms. And the young Griffin firing rooms, previously known the firing room 1, will be used for Artemis program. So now let's turn to the Space Launch System rocket. It's not a real picture. It's also an artist concept. I will show you the real picture because the real picture not for the entire rocket, because there are also the core stage, some parts of the rocket, such as the core stage. So the Space Launch System rocket is the largest and the heaviest rocket ever built. And before I start the explanation of this part, I would like to give you some background information about the units in the United States. So, Americans use the pound, the short ton, and the long ton, the metric ton, as units of mass, and I converted these units to kilograms, because I know that most of you know the kilograms and the grams, and I colored the last one, the metric ton, which is equal to 1,000 kilograms, because I will use it later. For length and distance, they use inches, feet, yards, and miles, which 1 feet is equal to 30.48 centimeters. Now let's come back to our rocket. This is the NASA Space Launch Rocket System evolution. You can see here 2 configurations of the rocket. Excuse me. So the 3 first ones are Block 1, such as Block 1 without crew, Block 1B with crew, and Block 1B cargo. And the last one is space launch system block 2 cargo. You can see here that the length of the rocket is between 322 feet and 365 feet, and the lift capacity is between 70 metric ton and 130 metric ton. For example, for the first rocket, I said the lift capacity is 70 metric ton. That means that this rocket can carry pilot as much as 70 metric ton. And to put it simple for you, I compared the first rocket, the first one, Block 1 without crew, to the Statue of the Liberty. You can see here that the rock is taller than the Statue of the Liberty, with length of 322 feet, and you can see that the length of the Statue of Liberty is 305 feet and 1 inches. So here are the two configurations of the rocket, Block 1 and Block 2. They have a core stage and 2 rocket boosters and 4 RS-25 engines. So I will talk the most important part of and heaviest part in the rocket is the core stage. I will talk about it. So the building of the core stage is in Massat Michoud Assembly Facility in New Orleans, and it is tested in Stennis Space Center nearby St. Louis, Mississippi. And of course, the launching will be at Kennedy Space Center in Florida. But now, how NASA will transport this heavy part, the core stage, between these three centers? Actually, NASA uses a Barge Pegasus. The Barge Pegasus was established and built, especially in 1999, to carry the giant tanks of the space shuttle from the shore of Louisiana to Kennedy Space Center. Then it had to be modified to carry the Space Launch System rocket. In this picture, you see here that the Barge Pegasus is carrying or carried the core stage Pathfinder on September 27, 2019. I will repeat, I said the core stage Pathfinder, not the core stage. And the core stage Pathfinder is a full-scale, similar in size, shape, and weight to the real core stage. And this photo, you see here the real core stage with the 4 R-25 engines. Here the team is transporting the core stage from the Michoud assembly building to the Barge Pegasus here. Now I will move on to the next part, which is the Orion spacecraft. This is also an artist concept. You will see the real pictures. So Orion spacecraft will take the astronauts to the moon, around to the moon. It will be docked firstly to the gateway. I will talk about it. Then we'll take the astronaut to the moon. So the Orion spacecraft is served as an exploration vehicle that will carry the crew to space, provide emergency abort capability, sustain the crew during the space travel, and provide safe re-entry from deep space return velocities. And the Orion spacecraft will be launched on the Space Launch System rocket. The Orion spacecraft has 3 main parts: the launch abort system at the top, the crew module in the center, and the European service module on the bottom. Here in this picture or in this GIF, you are seeing how the Orion spacecraft will be launched on the Space Launch System rocket. Okay, this is the test I will explain. Of course, before landing the humans on the moon, again, we should test everything, isn't it? So I have chosen for you some tests for the Orion spacecraft. This is the test of the motor, and this is it's called also the 30-second test. It is the third and the final test for the motor on February 25, 2020. The next test is the environmental testing at NASA's Bloomberg station in Sandusky, and this is the Bloomberg station. So the environmental test consists of two tests: the thermal vacuum testing, which is in which this Orion spacecraft was subjected to the extreme temperatures between -250 Fahrenheit and 300 Fahrenheit in the vacuum of the space. And the other test is the electromagnetic testing, which we should make sure that the electronics of the Orion spacecraft are working very well, probably when it operates. This is another test, which is the Orion parachute drop test. These three main parachutes will, of course, slow the crew here, the crew and the capsule, after the splashdown in the ocean. Okay. We have also the Orion underway recovery test. Here we can see that the team of the exploration ground system with the U.S. Navy are practiced in the ocean for recovering, because they will be responsible for the covering of the capsule and the crew. This is the test number 7 on October 31, 2018. This is also another test, the test vertical drop. So it's very simple. It's a water impact test, and the capsule here is dropped from 9 feet. This is the test on September 7, 2001, which is equal to 1,000 kilograms, because I will use it later. A water impact test, and the capsule here is dropped from 9 feet. This is the test on September 7, 2001, which is equal to 1,000 kilograms, because I will use it later. A water impact. Now to the lunar gateway. It is very simple. The Lunar Gateway is a new space station like the International Space Station, but it is much smaller. Its interior is about a studio apartment, whereas the International Space Station is larger than a six-bedroom house. This gateway, the Lunar Gateway, will be the home and office for the astronauts. The astronauts will visit the gateway once per year, but they can't stay a whole year like on board the International Space Station. They can just live and work on the gateway up to 3 months. So now the question: how will NASA build this gateway in the deep space, this spaceship? Actually, NASA plans to build the gateway with just 5 or 6 launches rockets. it will launch the major parts of rockets in multiple rockets. Some parts will be launched on VH rocket, and the other part, the most part, will be launched on the Space System Launch Rocket. So this is the power and propulsion element. And 22. Excuse me. And NASA has already started working on the gateway. Now for the lunar landers, actually I don't have many information. So this is the power and propulsion element. Has already chosen 11 companies to study. Of course, to study this